Well, okay. So let me first do a very brief introduction. I'm Guanjie Zheng. I'm an associate professor at Shanghai Jiaotong University. I think I don't need to introduce us to you, right? Actually, as you can see, I'm a little bit nervous, although I've been giving speeches, academic speeches, to a lot of people, but I think this kind of occasion is also very new to me. Yeah. So I've been prepared for these slides for quite a while, and I hope that we can get interactive in this speech. And if you can follow me, just give me more feedback. That will make me feel more comfortable, okay? So today I want to talk a little bit about how will AI reshape our city in the future. Okay, so before talking about the details, I want to first ask a question. What is AI? Can someone tell me what is AI? Just any keyword is okay. Artificial intelligence. Yeah, that's the key explanation. Yeah, but I will first start with some pictures. Yeah, it is not as long like 10 years ago. Now we are surrounded by all this kind of AI-generated content, like pictures, right? Can someone tell me which one of each of the four sets, which one is generated by people, which one is generated by AI? Or can someone give me some clue? Yes, please. Yeah, tectonic on the right. That is AI generated, right? Yeah, what's your clue? Okay, I see. Yeah, that's a good guess. Yeah, actually, I will show the answers here. As we can see that on the first row, both the right one are the AI generated content. I guess someone might find the clue is that like the coloring or the lighting, or there are some inconsistent things in the AI-generated content, while for the real ones, basically it's something like the pictures, right? Like we took photos, so it must reflect the physical world, in fact, right? So although AI has been very professional in helping us generating this kind of contents, it still has some problems. Well, here I give a further example on AI-generated content like text, right? How many of you have not used any AI-generated context? Have not? Okay. Yeah, I didn't see any hand, so that means all of us have been using this kind of AI-generated content, right? So what's your feeling when you are dealing with this AI-generated text? So on these two groups of texts, can you specify which one is AI-generated? I will give you a clue. Like here, we can see on the right side of the first row, there are so many itemized, right? So that means when AI is trying to generate something, it usually wants to give you some kind of guideline, which is represented as atomized. Okay, that's one key feature. And also, AI usually likes to use some kind of big words. Some words you might need to even look for the dictionary, right? Okay, so after these examples, I want to briefly bring you another definition, which is kind of the very first definition of AI. How many of you know Turing test? Or anyone? Yeah, I see a few hands. Okay, thank you. So Turing test is actually probably created about 80 years ago. Yeah, 80 years ago. It's an old test. It basically asks three parties to take part in this test. So on the left, there is a computer, player A. On the right, there is another human responder called player B. And we can serve as a player C, which is an interpreter. So when we will ask some questions to either the computer and the human responder, and they will give some feedback to me. After that, we will try to differentiate the answers from different responders. If we cannot tell which one is a computer, then that means the computer passed the test. So from this definition, basically we can know that actually the first definition of AI is pushing the AI try to imitate people so that people cannot tell whether this is an AI or human beings. So after that, actually AI has been developed so much so that it evolves several subfields, some of which we are very familiar with, like computer vision, natural language processing, and robotics. This kind of AI or AI applications has been around our lives these days. Traffic, pedestrians, other pedestrians, traffic signal, right? Okay, there are quite a few parties in this system. Yeah, as we know, we have vehicles, we have pedestrian, we have a lot of other unmotorized vehicles. So all of these parties, they are behaving in different patterns. They all have their own logic. Okay, but this kind of logic just does not work with each other. Okay, so how should we model this kind of complex system? And how should we try to negotiate with each other? Okay, here comes the first understanding. Before understanding the whole complex system, actually, we have to first figure out the fact, how many traffic are there in the city. So like 10 years ago or even earlier, people still need to work on the road to count the traffic by human and record the traffic on the paper. So basically, they write down the numbers of vehicles for each hour and try to give some explanation and adjust to operate the traffic. Okay, but it's just like the recent 20 years when the sensors is becoming more and more popular, we have the capability of having the whole city traffic monitored by the sensors. The sensors can be installed on the roadside. I believe that most of you have saw some road cameras, right? And also the sensors can be installed on the underground. If you see some kind of dark colored boxes on the road, then probably there's a sensor downward. Okay, so this kind of sensors basically tells you, this kind of loop sensor we call it, basically tells you how many cars are passing through. It can help you count the traffic. Well, nowadays, actually, the sensing technology has been developed so much so that we have a lot of other angles to see the sensors, to see the traffic. Now we have drones in the air. We have road cameras, right? This kind of sensors, this kind of cameras, they can capture all the traffic automatically and help you count, help you recognize the vehicles. Not only do they tell you the count, but they also can help you locate all the vehicles on the road so that you can see what is happening. Say there is a traffic jam or there is even an accident, right? So that's how AI helps us to recognize the traffic situation. Well, here we give another example, actually, which is also one of our work. In this work, we actually use an AI model, which is called graph neural nets. I guess maybe some of you might heard of that. So we use these graph neural nets to help us understand this whole traffic network system. So basically, we want to analyze how this kind of traffic congestion will spread into the whole city. And also, we want to detect which part of this road network is weak, so that we can try to get more measures to avoid this kind of bottleneck. Okay, then also for the large language models, we can also use AI to help us understand and assist us in trip planning. Say, if I gave the large language model a scenario where I'm going to depart from a location and I want to find a parking space, so the large language model can give me some suggestions according to my scenario. Okay, so after that, after understanding what the traffic is in the whole city, the next step you may want to ask is, how will it change? How will it be like in the next few hours? Will it be more congested, or I can go faster? Yeah, that's the second question we want to ask. So that's also where AI can help us a lot. It's like 20 years ago when we were given the sensor data. The first thing we want to do, if we want to predict the traffic in the next, say, half an hour, we may use some statistical models. I guess most of you might have known some ideas about this, like linear regression, right? This is a very basic and typical model in your statistic and in your math courses. Yeah, that's exactly what we are doing in the past, like 20 years. But now, with the technology of AI, with the technology of deep learning, we are able to convert it to a new style in which actually we can record the whole traffic in the city just like on video. Okay, if we see each time series of traffic in the world as a point, as a pixel on your image, then basically when you combine all these images, you get a video, right? So we can use the same techniques we process the video to process this traffic stream, traffic prediction problem. Then what is the typical technique we used in the past 10 years? It's called deep learning, right? I guess some of you might have heard of it, deep learning, right? So the key advantage of deep learning is that it can automatically learn from massive data without the human knowledge. That's why it's becoming much more popular recently, and it can really help us in getting a very accurate prediction. Okay, so after knowing what is happening in the future, in the very short future, we might also be curious, okay, even if I know what's going on, how can I change it? How can I try to go faster if I'm the operator of the whole city traffic? Okay, here I will try to make this traffic control problem as a game. Let's say traffic signal control, one of the things that may interact with the drivers the most. Okay, when we are running on the road, all the vehicles on the different directions, actually, they are competing for the green light, right? So what we are operating here is actually we want to give the directions the green light if this direction has more traffic. That's the principle that we all know. But how can we do that? How can we achieve this without doing too much transportation knowledge or doing too much transportation engineering? Okay, here's how AI can help us. If we try to formulate this problem and try to regard this problem, compare the city road network with a Go board. On the right, there is a Go board, right? If you try to regard each location, each intersection in this city as a cross on the Go board, then we can find the similarity between these two games. Why I'm saying it's a game, actually, on the right, when you are trying to get a good move, you are trying to guess how much chance I'm going to win if I put this move. Well, on the left, if you are going to change the traffic signal in the next 30 seconds, I'm going to guess, will I make the traffic faster or slower? Okay, it's all about the guess of the probability. So if you look at this problem from this side, then you can actually try to apply the same techniques, which is called deep reinforcement learning. This method is getting back to our vision like 10 years ago. And actually this team, they just, this big team, they just get the Nobel Prize this year, right? Yeah, so we can apply the same technique, which is called deep reinforcement learning, from the Go board to the traffic control system. And we can use this method to automatically learn a new strategy for this traffic signal. Okay, actually, we have been doing this for a while. We have been published almost 20 papers on this. And also, we have hosted a competition, a data science competition in the year of 2021. At that time, we hosted this competition with Guanjie Academy of Engineering in Hangzhou. Actually, we have been tested this kind of algorithm in several cities in China. And it do allow our traffic to have a higher throughput of about 30% improvement. Okay, so after all this kind of discussion, I think you may wonder, okay, with this kind of technologies, what will our city be like in the future? Well, different people may have really different opinions. Someone are against AI, someone may be in support. But one thing I want to point out is that no matter how AI is going to change, we have to face the fact that we are going to interact with AI. We will share the world with AI in the future. For example, which one is really changing our driving is you can see a lot of automatic driving car on the road right now. So we have to somehow learn how AI is driving so that we can prevent the risk. And AI is also going to learn how people is driving so that it can predict where we will go. So this kind of scenario is going to exist for quite a while, I believe. So that's one thing I want to share with you guys. But you may naturally ask, okay, can we fully trust AI? At least for now, I think the short answer is no. Because AI is going to still make some mistakes, and also because of the style, how AI is changed and how AI is trained, it can significantly make some big mistakes if you just rely on it. This is purely because AI is trained on a lot of data, and this kind of data can be easily contaminated or even by some malicious attack. So I do want to remind all of us, although we have to interact with AI, we have to be cautious and try to get an efficient but reliable way of using AI. Okay, that's all I want to share today. And I hope that some of you might get some take-home message and enjoy the lecture. Thank you.